Hello, we are Team 6. We will start the description of simulated environmental 2 that we was carried out from now. First of all, we will introduce the member of the team. I'm Shunta Nakanishi.
I'm Shohei Suguri.
I'm Shomai Yamashita.
I'm Shinya Yagi.
Our team has created an original audio player using Scilabo. We will talk about this audio feature that we've added under the program. The features that we have made are 5 in total. First is a volume control feature. Second is an open dialog feature. Third is a restart features. Fourth is a reset features. Final are frequency-based display and audio features. At first, we described a volume control feature. This feature is that we change the volume of listening music. We can change the volume with the slider on the right side of the screen. We can change the volume we can listen to music in our favorite volume. First program of line H slider is defined so that it is a slider. Next, we decided the position of the slider in the program of the second line. H slider mini and H slider max means that is max and mini of the volume. H slider volume value means that represents the initial position of the slider. We explain the content of H slider callback in the next slide. First line of the program is defined to make the function of the H slider. By writing volume equal H slider value, it indicates that the initial position of the slider is the music volume. This program is written in function called back play button. XBLK is defined that represents the volume is the first program. Second line of this program means XBLK is not allowed the larger than 1, and third line of this program means XBLK is not allowed the smaller than -1. Then when say y in this way, because XBLK is defined between -1 to 1. This page represents the audio graph of when the maximum and when it was in the middle of the volume. As you can see by comparing to the figure, by moving the slider, the amplitude of the graph is changed. And as you can see by looking at the figure of the right, the maximum volume of the amplitude, even if maximum of the volume does not exceed 1 or -1.
Next, I will show you open dialog. Open dialog is very convenient function and essential function for GUI. If you want to listen to many songs, you rewrite the code many times without open dialog function. So you may waste a lot of time. The function helps you to open other files. I show the open dialog code. First, we want to write the open button code. This code means you can make a button. Second, we want to write code to open a new wave file code. This code means you can open other wave files easy. Open dialog is very simple program and important function.
This button function is that it is possible to restart at the beginning of the music. When you listen to the music, there is a need to press the start button after pressing the stop button. The restart button avoids this process. The program was a function create GUI. The 6th line program evokes the function of the restart button. Next slide, we explain the callback restart function. 4-line program set state of the GUI stop. The 5-line program represents the callback play button function. So pressing the restart button is similar to pressing the start button after pressing the stop button. The left figure shows playing music. The right figure shows restarting at the beginning of the music. This button function opens the new screen and resets the state. This is possible to get the first state of the screen. These code and restarts are almost same. Different points are position and callback function. On next slide, we explain callback reset button. Second and third program means that press the stop button, disappearing open windows by the fourth line of the program. The next line opens screen of the new GUI. The program after the create GUI line turn off the graph. The left figure shows listening to another song. The right figure shows reset to show the first state.
Next, I will introduce time and frequency-based display code. The main function is to change the time-based display to a frequency-based display. So, we get time and frequency information in one window. First, we made the time and frequency buttons. Next, we made the function to set time frequency state. The code is here. We define state 1. State 1 is the time and frequency state. Please show this figure. In this function, if state 1 is time, the time button is not enabled, and the frequency button is enabled. And if state 1 is frequency, the time button is enabled, and the frequency button is not enabled. Second, we made time and frequency based display in graph. This function is to choose time-based plot and frequency-based bar chart, and to display the graph. If each time button is enabled, state 1 is frequency, and we display frequency-based bar chart. If each time button is not enabled, state 1 is time, and we display time-based plot. Finally, we made callbacks for the time and frequency buttons. The code is here. In function callback frequency button, if you push the frequency button, we set the time frequency state to frequency. And in the function callback time button, if you push the time button, we set the time frequency state to time. So, if you push the frequency button, we can see a frequency-based bar chart. And if you push the time button, we can see time-based plot.
I say again, our objective is to create original audio player GUI. So our next change is a more comfortable GUI. For example, I want to add a remote control function. Remote control function helps you to use the GUI with very simple mobile system. In a sense, YouTube is a famous GUI. YouTube has many comfortable features, repeat feature, comment feature, and so on. So our goal is comfortable GUI like a YouTube. That is all. Thank you for listening. Goodbye, Chandra. Thank you, Chandra. Forever, Chandra.